An exponential function has the form y equals ab to the x. Now that's opposed to a power function which has form y equals ax to the p. I just use p because that's the power of x, right? Okay? So for example, if a is 1 and p is 2, that's y equals x squared. That's your basic quadratic function, right? If p was 3 and a was 1, you'd have the y equals x cubed graph. If you put a in there, you vertically stretch one of those graphs, right? Okay? So this is just a vertical stretch. Or, the inverse of the squaring function is the square root function. Turns out that's the 1/2 power function. So if p was 1/2 and a was 1, you'd have the basic square root function. Okay? Inverse to the to one branch of the squaring function. Okay, I say this and I want to compare it with this. What's the difference between this and this? They look almost the same, don't they?
The x is in the exponent?
Yeah, well in this case, where's x? It's in the exponent. Gee, why would we then call this an exponential function? Okay? I don't know. X is in the exponent. We call it an exponential function. Oh, gee. Okay, well, we can probably see the connection, right? I say this because it's really easy to confuse these forms. Okay? Here, x is not in the exponent, so this is not an exponential function. It's a power of x. So it's a power function. We haven't really talked specifically about power functions, but we've done a lot with the squaring function. Okay? And we've graphed the cubic function. We know what to do with it. And we've graphed the square root function, which is the 1/2 power function. So we've seen examples. Okay. We haven't done as much with this, but we're about to. Okay? Okay, so we have exponential functions. There are power functions that we've seen some of. What's this?
Quadratic.
That's a quadratic function. What's the very first thing we did with quadratic functions? We took this form and we modeled the depth of the water as water flowed out through the side of the container, right?
Yep.
Okay? What's this?
A linear function?
A linear function. What does that? All kinds of things, right? Okay? Okay, so we have 4 kinds of functions here. We have power functions, exponential functions, quadratic functions, and linear functions, right? Now notice that the quadratic function is really a sum of power functions. AT squared is a power function, right? I mean, we've got t instead of x, but that's okay, right? Okay, p would be 2, right? BT is a power function. What's the power?
0.
That'd be 1.
Yeah, t's raised to what power? To 1.
1.
So p would be 1, right? And instead of a, you'd say b, but, this form fits this, right? And c is a power function.
This is 0.
0 power. If a is c and p is 0, then you get just y equals c, right? So this is just a sum of power functions, okay? And that's what a polynomial function is.
Polynomial was what?
It's a sum of power functions, but there's a restriction. You can't have just any power, like the square root. That's forbidden. It's got to be integer powers, and the integers can't be negative.
So it got to be like 4, 6, 8, 10, 12.
No, well, integers include 1 and 3. They can be even or odd, okay? And actually, I'm sorry?
Like an integer is not a decimal or a fraction.
Yeah, integers are just basically, okay, you got whole number, well, you got your counting numbers, right? Those are numbers that you count sheep with, or whatever you did when we were in an agrarian society, right? Bushels of corn, whatever. Okay? Then you extend that and include 0. Okay? Why would you include 0? If you don't have any sheep, you don't have any sheep. Why do you have to say, I got 0 sheep? People got killed over this.
Because it's numbers between
The
0
idea of including 0. so you could do certain types of arithmetic, okay? You know, they're the big, in the Middle East, naturally, that's, well, that's where civilization started, that's where a lot of stuff went on, right? Okay? In Middle East and India, you know, there were wars, maybe executions at least, over people that believed you should have zero. Kind of like politics today. So, you know, different, we're not really doing executions here. Okay, so anyhow, you extend the counting numbers, the sheep counting numbers, and you include zero. Then you say, well, if I go down from 1 to 0, I could keep going and get -1 or -2 or -3, and that's in the integers. Okay? The counting numbers start with 1, so nobody gets hurt. Okay? The whole numbers start with 0. Okay? And the polynomials are combinations of these where p is just whole numbers. Okay? That's a preview. I'll define that more carefully, but that's pretty much your definition. So I'll probably say it a little faster next time. Okay, well, now that I've defined polynomials, I'm going to start another video because this is getting a little long. These are supposed to be brief summaries.